Hello everyone, this is Group 10, which includes Xinwenji, Zheng Yifang, and Qian Zhen. This research topic that we will discuss is about the strengths of trained soil. Next. In the section of introduction, I will give definition of soil strengths and the corresponding influence factors, the introduction of trained soil and the aggregates of rubber and cement in the application of soil. Next. So, what is peak shear stress? From the diagram for the relationship between shear stress and the deformation, we can say that the shear stress changes with the deformation. From the beginning, shear stress increases with deformation at a deformation value. There is a point that it has the maximum shear stress during deformation process of soil. At this point, we call the shear stress value as peak shear stress. After peak shear stress, the shear stress decreases with deformation, which is plastic deformation. Finally, shear stress remains unchanged with increase of deformation, which is critical state stress. Peak shear stress exists in dense soil and doesn't exist in northern soil. It has been influenced by various factors such as density, temperature, time, strain rate, and confining stress, artificial treatment. Next. Trained soil refers to the natural soil that has been artificially processed. It can be the method of trained soil by mixing different additives, including cement reinforcement, fiber reinforcement, rubber reinforcement, whereby other methods of geograde contamination. Trained soil may be positive in the engineering practice. Therefore, further analysis is necessary. Next, please. Rubber and cement are shown in the left side and the right side respectively. The color of the rubber is black, and the color of cement is usually green. Rubber and cement are the common additives in soil, and the rubber is mainly from waste rubber, which is positive for the environment if it is used in soil. We can see from the diagram of rubber, it's required to be cut into small particles, shapes, and then mixed with the soil. The picture in the right side is the cement. It's a bonder used for construction that adheres to other materials to bond them together. It's powderful and used to mix with soil in this research. Next, please.
Hello everyone. I will describe the research progress. In the research progress, there have three parts: the soil mixed with the rubber and or cement, and relevant research method and the research result. Next. And there are two types of the soils in the experiment. The most important one is side and gravelly soil. There are just a few cases where the clay is used. And for the material mixing types, we can see the picture. For the rubber, particle shapes and diameter relevant to preparation in the soils will affect the property of the treated soil. And for the cement, the content of the cementation agent will affect the property of the treated soil. And also, if we want to use the cement to improve the soil, first we need to add the soil and the cement to mix with the water. So the water content is a key feature to the cement. And also, we can see the different shape, the shape of the different shape of the specimen will affect the treated soil also. Next, please. And for the relevant research method, there are three methods. First one is a unconformed compressed stress test, and the directly shear test and triaxial compression test. And the last one is most important, and almost all the experiments use it. And the last price clearly show the magnetic property of the treated soil, such as the axial stress and axial displacement. And it is also convenient to compare and analyze the performance of the soil and the peak shear strength. Next, please. And this is a research result. For the rubber, the mechanical property of the side, the peak strength and the residual strengths are improved. And the various volumetric preparation of the rubber in the soil affects the peak strength. And we can see the picture. The form of the rubber has an effect on the strength. The fiber rubber provides the greatest shear strength. And comparison of the different form of the rubber, the strength of the mixture containing crab rubber increased by 10 to 25% as compared to the mixture containing rubber powder and the various confinement stress. Next, please. For the cement, the addition of the cement to the soil increases the stiffness and the peak strength. If the fiber reinforcement used to mix the soil, the peak strength will be further enhanced. We can see the curve in the figure. And also, the degree of the consolidation of the cement and the soil will affect the peak strength. In the table, we can see for a curing time of between 1 to 7 days, the higher degree of the consolidation of the cement and soil will cause the maximum shear strength. By observing the largest peak strength specimen, we can find that isotropic consolidation pressure and the confining pressure is also the largest when compared with the same types of the specimen. Next, please.
Okay, in this part, I would like to talk about some other points about the research results. In case of rubber addition, it is found that different types of rubber mixed in soil could have different impacts on soil properties. Like for granulated rubber mixed in gravelly soil would decrease the shear strength of mixtures due to soft particles in load transmission increased. But if dune soil mixes with rubber fiber, the shear strength will increase because of the level of densification achieved. The difference is mainly dependent on the addition mixing method in practical operation. Also, in case of cemented soil, the peak strength increases due to cement fiber inclusion, as well as the residual strength. And it is found that the friction angle is increased from 35 degrees to 46 degrees as a result of fiber inclusion. That is why peak strength increases. However, some research methods only consider one variable, such as only 12.8 millimeter of fiber length considered. For the other variables, like different fiber lengths, curing time, and the consolidation pressure could be investigated in the future research. When it comes to significance of shear strength in engineering practice, it is a key factor for designing geotechnical structure such as shallow or deep foundation, excavation, and stability of slope. And obviously, the treated soil with enhanced shear strength can improve the bearing capacity of foundation and stability of returning wall and the slopes. As a result, some kind of construction cost could be saved. For this research of strength of treated soil, two types of engineering additions, rubber and the cement, are selected by our group to investigate. After literature review, it is found that the properties of treated soil were improved in different degrees with the addition in different forms. By controlling variables method, the relationship between particular influence factor and the soil performance could be obtained. And some kind of gaps of research method discussed in the literature should be considered as well. Overall, for different practical engineering environments. Considering the effects of all factors could help one to choose more reasonable and reliable construction method. In other words, reasonable construction can be given according to a series of material characteristics. And this is our group of work breakdown. Chen Zheng works for introduction and literature review. Zheng Ying Huang works for research method and the results literature review. And I work for critical analysis or engineering practice and conclusion and literature review. And this is our group for 7 reference lists. Thanks.